question says let a salesperson receives an annual salary of 6,000 plus 8% of the value the order she takes. The annual values can be represented by random variable with mean 600,000 in standard deviation. Find the mean and standard deviation of the salesperson's annual income. So let's let x, because this is like the random variable they've given us. Like let's do it here. Just a sec. Right, so the annual value of these orders, right? This is the x, right? So let x, so let x be annual value of orders, and let y be, we want to find the standard salesperson's annual income, right? That's what y is going to be for us, right? What you want to find, it's the linear function of x. Let y be, so sorry, salesperson's annual income. So the first thing is we defined the two random variables. The first was x, which is the annual value of these orders, and y is whose expected value and ST we're interested in, right? It's the salesperson's annual income. Now, based on the question, you can see y is 6,000 because the salesperson receives, like if we just look at this, so they have told us over here, a salesperson receives an annual salary of 6,000 plus 8,000 of the value the order she takes, right? So they have defined y like this, that y is equal to your salesperson's annual income. It's an annual salary 6,000, right? So let's just forget this and let's just write this 6,000 plus 8% of the value of the order she takes. 8% of the value of the order she takes. Like, let's just write it as 0.08 instead. We could write it as 8%, but let's just write it in decimals. 0.08%. So 8% of the annual value for orders she receives for X, right? So based upon the information given to us, we have to find X as the annual value for orders, Y is the salesperson's annual income, and based on the information given here, we can write the salesperson annual income is equal to 36,000 plus 0.08 i8% times the annual value for orders she receives. Now let's find expected value of Y. Expected value of Y is expected value of 6,000 plus 0.08x. Now we're gonna use a property of expectation. Using property of expectation, that expected value of ax plus b is equal to a expected value of x plus b. So basically, expectation of sum, expectation can go inside sums, constant, like expectation can go inside sums, right? You can write expected value of ax plus expected value of b, and then constants can come outside of expectation, like over here a has come out, and expectation of a constant, just a constant, just like expected value b is just b, right? That's how we're doing it. So here a is 0.08, so if we just show, now let me just connect these, right? So here a is 0.08, and let's use this, and b here is 6,000, right? So we're just going to use this property of expectation, and based on that we can say the expected value of y is just going to be 6,000 plus 0.08 expected value of x. Let's just clear all of this up. So we've written this, the expected value y is 6,000 plus 0.08 expected value of x. Now, since expected value of x is 600,000 given, right? Where is this given? Let's just quickly look at that. Right, it's given to us over here, right? Expected value of x. So this is 600,000, right? So expected value of y is just 6,000 plus 0.08 into 600,000 is equal to 54,000 expected value. Let's find, now we want to find standard deviation of the salesperson's annual income, which is y. So we want to find standard deviation of y. For that, we'll first find variance of y, and then you can just take its square root and find standard deviation of y. So variance of y is going to be variance, like we define y to be 6000 plus 0.08x. Now, using the property of variance, that variance of ax plus b is equal to a squared variance of x. So variance of y is just going, now okay, over here let's just see what each of these represents quickly. Right, so a in this case is just 0.08, and b, oh sorry, b 6000, this case b in this case is just 6000, right? So if I do over here variance of y, so it's a squared, so it's 0.08 squared variance of x. Now, since variance of x is 180,000 square, right? 180,000 square it's given, right? So we're given SD, I've just taken a square of it, right? So we're given the SD over here. If we just quickly look at this, we're given a standard deviation of 180,000, right? So this is the 180,000 standard deviation given. So we just take a square of it to find the variance, right? So so then variance of y is just 0.08 square into 180,000 square, right? Because 180,000 is the standard deviation, so variance of x will just be the square of that. So variance of y. So now we know standard deviation is the positive square root of variance. So standard deviation of y is just this positive square root of variance of y. So this will just be the square root of 0.08 square into 180,000 square. And this will just turn out to be 14400. So in this way, we can find expected value and standard deviation of a linear function random variable. You can find its expected value and variance using the properties of expectation and variance. And once you have the variance, then you can find the standard deviation of this positive square root.